Here we can see the complex z-plane, and we have here the real and the imaginary axis, and we have values for when omega equals to 0, omega equals to pi, and here is the unit circle where omega is equal to e to the power of minus j omega. And here we can see that in general we obtain a 2 pi periodicity in the frequency domain because of the 2 pi periodicity of the exponential function e to the power j omega. So we also observe that for real valued signal, the spectrum of the negative frequency is the conjugate complex of the positive frequency. This is also a very important property for real valued signals, and here this star denotes the conjugate complex operation, because in our TTFT, so we have e to the power of minus j minus omega n is equal to the complex, the conjugate complex operation. So is the conjugate complex e to the power minus j capital omega n. We also have to use the fact that the conjugate complex of a real value signal does not change it to draw the conjugation out of the Fourier sum. So this also means that for real valued signals, we only need to look at the frequency range between 0 and pi, because the negative frequencies are conjugate symmetric. And because of the 2 pi periodicity, the range between minus pi and pi is also sufficient to look at. This is also, again, what the Nyquist theorem tells us, that the frequencies between 0 and pi, the Nyquist frequencies, are sufficient to completely describe a real valued signal. So this is a very important property, that for real valued signals, the spectrum of the negative frequency is the conjugate complex of the positive frequencies. And then we have this, what the Nyquist theorem tells us, that the frequencies between 0 and pi are sufficient to completely describe a real valued signal.